Okay.
Thank you.
Sorry, Steve, I just didn't want to sidetrack you while you were
It's all good.
working on Herc.
Oh, look at that.
That's cool.
Yeah.
Yeah, it's interesting structure.
It's like tweaked columnar jointing.
I was going to say it looks like the Iron Throne, but yeah, that too.
That works.
What did you describe it as, Andrea?
I just said it looks like tweaked columnar jointing, like columnar jointing was trying to happen, or maybe that's just manganese crust covering columnar jointing.
What is columnar jointing?
When basalt cools, it kind of pulls away from each other and creates these hexagon columns. And those look like classically what they would be, but they would not be rounded like that.
Right. Is that like that famous place in Northern Ireland?
Yes, that's exactly the same.
Giant's Causeway.
Yep.
So we have about 35 minutes left on our shift before we hand it over to the next watch.
What was that cave you were talking about, Gabby? Do you want to go to SPL?
Like Fingal's Cave, I think it's called. Is that the Irish one?
The one, Giant's Causeway is the one I was thinking of. It's on
Okay.
the northern coast.
Iceland has some great examples of it too.
Yep.
You can also find it in the Columbia River basalts in Oregon and Washington. Some of them are carved out by the Great Missoula floods or the Ice Age floods. So you could see them in Moses Coulee and Grand Coulee, where you have big gashes in the Columbia River basalts that are a large igneous province that takes up a large portion of Washington.
No, we have,
moving north.
and we just wrapped one up.
Yeah, I'll get back out in the end of my leash here, and then we can dial in another one.
So we have a question coming in from the nautiluslife.org website. Is the dark color the coating, or is the dark color the underlying rock?
So there is a dark color that is the manganese crust. A basalt, when it erupts, is already a dark color. The differential dark color that we think that we're seeing, which is like the darker black color, looks like it's a polished surface where sediments are actually working to, the coarseness in the sediments are abrading and polishing off. Probably some of all of the, it looks like growths or that kind of like spider web film.
Okay, I think we're good for.
So we think that that's a polishing of the rock.
Ridge, this is Nat.
Look up a bit for me, Gabby.
We're ready for another move. May we please move 30 meters bearing 360.
That is another fantastic rock. Look at that.
Thank you, Alex.
So another question coming in from one of our viewers around the world. This seamount is completely inactive now. It has not erupted in, well, we're not quite sure how many years, but a lot of years. These seamounts, we think, are not related to the seamounts that were created by the Hawaiian hotspot. Can you talk a little bit more about that? And if you're watching at home, you might want to pull it up on Google Earth and see these different lines of seamounts that we're exploring.
Right, so the when we have volcanoes that are derived from a mantle plume, it is largely hypothesized that a mantle plume is relatively fixed over geologic time, so on the order of tens of millions of years. It occupies the same space, but the tectonic plate moving above it does indeed move. As it moves above it, it creates a line of volcanoes because as the forming volcano moves away from the plume, it dies and a new one is generated. What that creates is a track of volcanoes that we call an age progressive seamount chain. And each of them get older as you get farther away from the plume. The Hawaiian Ridge is associated with the Hawaiian plume that is currently creating the big island of Hawaii, and the farthest seamount away from it is approximately 48 to 50 million years old at the Emperor Seamount Bend, and that's part of the Hawaiian Ridge. Then the plate moved at that time, approximately 50 million years ago, and changed its orientation. And when it did, it created the Emperor Seamount Bend, and then we have the Emperor Seamount track. That is the track that was formed from approximately 50 to 80 million years ago. The seamounts that we're looking at today do not have the same orientation if you go from seamount to seamount and kind of did like a connect the dots situation. It has a different orientation than the Hawaiian Ridge, and so we are examining what plume they might have potentially been derived by and how long ago they were formed and how long that plume was active over. So right now I think the oldest known evidence of a plume is that that plume was alive for 120 million years. So they can occupy the same point at the core mantle boundary for a really long time.
Where does the 120 estimate come from?
I don't know which plume that is. I think, well, I'm not sure, but I remember thinking that there is a plume that is older than 80, there's more than one plume older than 80 million years. And I can't remember the exact seamount track, but I can look it up. So 120 million, but remember that the oldest crust is in between 180 and 200 million years old. So even if you had a plume that was older than that, you would have no evidence of it because that crust would be subducted.
This looks like more of that spiderwebby material that we were seeing earlier.
Yeah, and I'm wondering if that's either part of a sponge or, like I said, something is laying its eggs, and that's that'd be a good question for Chris Kelly. Brittle stars taking up spot there.
It's like a hammock.
Yeah, a little hammock.
Something iridescent in there. Okay.
So throughout the Pacific, you have these different lines of volcanoes, and they're not all parallel to each other. And the way it was explained during one of our science meetings, one of the best things about being on board Nautilus is that we get to learn from the experts who are here with us. The way it was kind of explained is that if you came across a beach that had several lines of animal tracks,
Steve?
Sorry about that.
Thanks.
it would be important for you to know not just which animals made the tracks, but also when. They might not have all been there at the same time. So one of the things that we are here to do is collect these rock samples to try to figure out how long ago this lava was erupting.
I think we're good for another one.
So that we can figure out which
Bridge, Nav.
track came first.
Can we make that same move, please? 30 meters, bearing 360. Perfect, thank you.
I really like that animal track analogy because not only do you not know which came first, but sometimes you can't tell which animal, like which direction it went in.
Sure.
Because you're like, oh, is this the line that it took, or is this the line that it took? You can't, when they all intersect.
Right.
And that's, I think, part of the challenge with the seamounts and the ridges.
Yep. We need Andrea date them for us. We know which direction it went.
Yeah, luckily they have trace chemistry that tells us that, that is somewhat diagnostic of the plume itself and the ages, but together that gives us a good amount of information to reconstruct the plate motion as well as the plume location. Here's another beautiful sponge.
Yeah,
Same, looks
fourth
like,
one.
yeah, the fourth one, and it looks like the same species. Just fantastic. I agree. I can't remember who said it looks like it comes out of a Dr. Seuss book, but it definitely does.
They've all been this orange.
What's that?
They've all had this orange color. The ones,
Oh.
the closest one I've found in the OER guide was yellow.
Gabby, can you pull up the DSC cam on that far left?
And there you can
Monitor
see the
left and then still cam there.
resident shrimp there.
Yeah, there was a resident shrimp. Looks like he's in there. It was interesting that we saw those baby shrimp in that one, though. That was, I didn't expect for so many of them to be there. I didn't expect for any baby shrimp to be there.
This one's in a good spot to get in the digital still cam, so I'm gonna take a minute here and
Can you turn off the lasers, Gabby, when you get a second?
We don't have anywhere to put a sample, do we? No.
I don't know if putting it in with the rocks would contaminate those samples or cross-contaminate them.
that thing take a picture yet?
I've taken a lot.
I'm watching the digital still camera, trying to
Okay.
see if it takes that thing on the left. Should be within 30 seconds. There it went. Okay. Thank you. Wow, what's up with that? Your monitor's all blurry.
We're zoomed in on it.
But it's different on, I think you, yeah, wrong button. How are we doing on time and progression? Are we too slow, too fast?
I think we're making as best we can, right?
How far away from our end target are we?
Ooh, give me a second.
Is that
Out.
Oh, no, that's another coral.
Say we're making pretty good time.
What's that, Emma?
It looks like we're making pretty good time. We're at the 2700, almost 2800.
Yeah, and that in target is
Sorry, Gabby, say again.
1.6 kilometers away.
Yeah.
Thank you.
Okay, I'm trying to get a feel if you guys want to keep zooming on every coral we see or just keep pushing on.
I think we should keep pushing on because we're hoping that we're going to get into denser communities.
Copy
Yeah, And if we get to the end target, you know, they could keep going.
Okay.
Till
Bridge, nav.
about a 06.
Can we move 50 meters bearing 360?
So at 15 meters a minute, it'll take a
What's that?
2 hours, 40 minutes or so to come up.
All right.
So that next watch will be a short one. Well, short time on the bottom for their watch.
It's the rock star watch for us. Oh, I'll take more of these.
They're loaded. Loaded up.
Slipper shift with no blue water. Doesn't get much better than that for us.
A lot more nodules here.
I think it's seems kind of like it's flattened out a bit. You could do the constant move again if you wanted.
Same moves.
Yeah, you can keep it moving now.
All right. We're 45 meters away, but I can increase the speed maybe, or just keep her moving.
Just keep it moving. I switched to the step moves there when we were coming up the cliff.
Yeah.
Because I didn't know how steep it was going to be.
Same speed or maybe a little faster?
That 0.2 or 0.3 seems to be a good speed.
Bridge, nav. Can we jump this move 50 meters, bearing 360? Yeah.
If you're just joining us, thanks for watching. We're here exploring Papahanaumokuakea Marine Monument. So far on this dive, we've collected quite a few rock samples. All of our rock sampling locations on the ROV are full. Also seen quite a few sponges and corals. And we are continuing upslope to see what else we might be able to see here.
There's another sponge in the Argus view.
Yeah, something white up there.
Another Dr. Seuss sponge.
Looks like it.
It should make you happy, Gabby, to hand it over. And I'm sorry, all the boxes are full. Yeah.
Look at that sponge.
Same one.
You want to pull the DSC up again? We'll see if he's perched on the rock there. This would be a great one to do a 3D.
He actually looks a little different. He has a different stalk.
The stalk looks much
thicker.
different.
Yeah.
What's this black thing on it?
I don't remember ever seeing a sponge that looked like this
What's going on
one.
with all the vignetting on this camera?
It's,
yeah, we should do a 360 on this guy.
Yeah, 360 might be good on this. Is that possible?
Absolutely.
All right.
That looks
Oh,
like,
there's the stalk.
Oh, there it is.
Oh, there it is.
that looks like you're seeing some of the housing, the underwater housing.
Yeah, it's just weighed down by itself.
Yeah, but I'm just going to adjust this camera here so we can also get it in the digital still.
Oh, it's a
This is
pressure
coral.
port.
the coral underneath it. Yeah.
Oh.
He edits those out. The
Okay.
Prime real
things from-
estate. It's a fantastic sponge.
Gabby, can you come down 5 meters?
Yeah, sure.
10 meters, maybe. Need a little
Chris
more
is
relief.
going to be really
Man,
happy
you're
with all the
killing me.
sponges that we've seen.
Oh, we can put the lasers back on, I think.
Okay, roger that.
Thanks.
Lasers coming on.
Big and healthy, apparently.
I can't get it in both cameras this close. So. Oh, there it is.
Actually, I'm sure he's down in the lobby right now. He's in the cafeteria now looking at this.
You get enough pictures, we can do some photogrammetry with this guy.
Sure. We have some more polished rock associated with these brittle stars and this sponge. So again, I don't know if that's current doing that work or organisms or both.
We want to hold
squat
off on the
lobster.
zoom, Steve.
You want to zoom?
You can zoom back out just a bit.
Oh yeah, squat lobsters in there.
We're doing
And
a
a shrimp.
360, so if
Oh,
they
sorry.
want photogrammetry, they'll need more of the background there.
So Data, how many Niskins have we pulled and how many do we have free?
Looks like we have 3 left.
3 left, yeah. 1, 2, and 3 are open.
Thanks, Meredith was asking on the science chat.
Oh,
Thank you.
Taking a look at this sponge and coral and brittle star community here.
Seems to be a rock
Thankfully,
in my way. You can come up a bit now if you want.
I do want.
Yeah, I'm putting a turn in the tether, so we might want to keep it a little tighter than.
Okay.
Stretch it out a bit so it doesn't tie itself in a knot.
So we're getting a couple questions in from viewers. Someone wants to know, is this a plant or an animal, and how does it stay attached to the rock?
Yeah.
that's a great question.
That's a great
So
question for Chris.
I'm going to do the same thing, guys, a little
He should be
bit
here in
further
13
away
minutes.
and looking down just to take that turn out.
Probably an
Um,
I
animal.
can feel the first half.
Yeah, go ahead.
Definitely an animal.
We can do a little zoom on this one, Steve. I'm going to look down more, so zoom in just a bit. That's good, thanks.
Sponges have evolved in this microbial soup, and they have got some amazing compounds in them that have proven beneficial to human health. Some cancer-fighting compounds have been derived from deep-sea sponges. But how these animals, I'm not up to speed on the cement that they use to hold on to those rocks, but they're adapted to live in a strong current. Some of these glass sponges have amazing structural strength and are being studied by engineers.
And when you say it's an animal, it's a lot of little animals, right? It's a colonial organism, just similar to how corals are colonial?
Corals are colonial. I don't think you consider a sponge a colonial organism. No, this is one organism.
Fantastic.
And it has been around, sponges like these have been around for 500 million years.
That's a long time.
They appear in the Cambrian explosion or before?
They are, I can't remember if they are before, but they are definitely they are the first multicellular, some of the first multicellular organisms.
Okay, that's a pirouette and a reverse pirouette.
Good job, thank you.
Very nice.
My pleasure.
Great job.
I think we were headed north, right?
Yep.
So we'll have to pass that question about how these sponges attach to the rock off onto our next watch when they join us in just a few minutes. You might get a more satisfying answer from there. We change watches every 4 hours. We're coming near to the end of our watch. We will be passing it off to the 4 to 8 watch. Wow, look at all those brittle stars.
Hey, can you get the ship to hold position, please?
Bridge, nav. Hold position, please. Thank you.
I just saw a cup coral to the left.
You saw a cup coral?
Yep.
Where?
Back left. On the other side of that. You can just see the top of it there.
No way. Look at that. I don't think we've seen one of those yet, have we?
Is that a cup coral?
I think that's
an
an
anemone.
anemone.
Oh, sorry, I got tricked.
Is it similar to the one that they collected yesterday?
Bring your head to 330 where you go.
Looks okay.
I don't think that's a cup coral.
No, but first anemone like that we've seen, right?
Yeah, we haven't seen one of those.
Yeah, looks similar to the one that they got all excited about yesterday that they collected.
This one seems to have longer tentacles.
Okay, Steve.
Good eye, though.
Yeah.
Do all anemones sting or just some of them?
I do not know.
I don't know either. I probably wouldn't want to get too close to that guy. Looks like he means business.
Zoom a bit more.
I think the stock on the one they collected yesterday looked smooth, but this one,
It
That's
was
good, then.
ridged but not bumpy.
yeah.
Yeah.
Beautiful view.
Oh, Meredith came in on the chat saying that all cnidarians have nematocysts, but some of them are more sticky than toxic.
Oh.
Thank you, Meredith.
Meredith came in last night and told us that the Christmas tree coral came from the Southern California bight, and now she answered this question for us this evening. Or I should say early morning now we're in.
Glad to have Meredith with us.
Yes.
Absolutely.
Okay.
So we're getting a viewer question about what the process is here for handing off between watches. So we have about 7 more minutes left on our watch, and then near the end of our watch, we will go radio silent to observe some protocols. We'll do that in a few minutes. And after that, we will be off SPL, speaking with our counterparts. Each station swaps out. We update our replacements on where we are in collecting data, collecting images, collecting samples, where we are in navigating. We will talk to them about all of those things for just a few minutes, so you won't be hearing us on SPL. You'll still be seeing the cameras. And then those of us who've been on since midnight local time will go off and either continue our work or maybe grab a snack or some sleep. And the new folks will be on. I think this dive is scheduled to go on for about another 4 hours, so lots of action coming up. We never know what we're going to see, so stay tuned. And we'll be going to watch change in just a few minutes.
Well, there's some beautiful corals on the horizon.
It's a good Argus shot there.
Uh-huh.
I'm gonna come, let's hold that and I'll come, I'll land for handover.
Okay. Oh.
Yeah, still suck. Hey, Steve, you still there?
So if you're watching on Nautilus Live in Sat Feed 3, you can see the control van. Folks are coming in to relieve each other and catching up. If you're curious about that process, you got a really good view of it on Sat Feed 3. We run 4-hour watches so that people don't get too tired. Got a question here about how caffeinated we all are, and I think it varies person to person. I myself am so excited to be here. I haven't needed to caffeinate too much, but I think everyone's having their own experience with that. So we're going to go off SPL here while we switch out everybody at their stations. We're going to leave you with this view here. We'll be back with you in just a few moments when everybody gets settled for the new watch. Thanks so much from the 12 to 4 for following along. We are going to be continuing diving for 2 weeks, so stay tuned to nautiluslive.org. This dive will continue for another 4 hours, and we'll probably be diving again later this afternoon. So although our time with you is up, the exploration never ends. And we'll see you soon.
Audio check. Audio check. Hello, Trevor. Full wide? Yep. That's full wide. Cool, thanks. Yep. Were you talking to me, Trevor? Okay.
Yeah, but DVL has ground fault, yeah. Okay. So they're just going off USBL. Okay. Yeah, it looks fine. I guess it got a bit sketchy for a while, a bit spotty, but it looks good now. All right, getting situated. All right, ready to go then. Let me just zoom out a little bit. What's your heading? Do you like that? Do you like your heading, 341? You're kind of oriented on the ridge. Okay. Okay. Here we go. Bridge nav. Good morning, Martina. Can we get a 20 meter step bearing 350? Thank you. Good morning, science.
Good morning, front row.
Are we still aiming for 8 o'clock recovery?
Yes, we are. Thank you.
All right, and Trevor, are we still 15 meters a minute up?
For recovery?
Yeah.
Yeah, I think that's about right.
So that's putting us at a 3 hour approximately.
Okay, sounds good.
So we only have about an hour left with that schedule.
So, Trevor, I have a question. Excuse me, pilot. I have a question for you.
Yeah.
And that is, apparently, all the boxes are filled with rocks, and there's no biologics. So, is there a way that if we see some, we can figure out how to get a couple biologics?
Sure, yeah, of course. I mean, so there's all sorts of options with that. So if we have, like yesterday, an anemone stuck to a rock, I'd be happy to put that in a box and share the box. But if they need to be separated, then that might not work. But we can put two things in one box if it's okay with the back row. And other options are small things. We can slurp them, put them in the suction jars. Even small, like really, really tiny rocks with some life on them, we can put up into the suction system.
Okay, well, I'll keep my eye out for some small collectibles. I'm aware that the rotary thing is pretty much empty.
Yeah.
But I was watching for a little while, and I did see a few things that might be good collections. That's why the question. So we'll just keep an eye out and see what we can do. Okay,
yeah, great. Yeah, just say the word on something you want to try, and we'll see if we can figure out a way to make it happen.
Okay, thanks a lot. Appreciate it. So should we do a little intro to the back row, and then also are we going to do the ceremony, I think, at the beginning of the watch lead, or how do you want to do that?
I think.
Yeah, what's that? At the end of the dive? Well, I guess I'm asking, do we need to do something right now as we're starting out, or we don't? So it'd just be at the end. Okay, great. Got it. Thank you.
Well, good morning, everybody. This is Aphrodita, starting our watch here while we are observing what Hercules is showing us from the bottom of the ocean. And let's do an introduction to see who's here. So we'll start with science.
Okay, hi, this is Chris Kelly. I'm with the University of Hawaii, and I'm a biologist, and I'm looking for strange creatures to get some video of and possibly to collect if we think it's something new. And to my right.
Aloha, good morning. My name is Kainalu Stewart. I'm the data logger for this shift, and yeah, really excited to be here.
Oh, we can hear you.
All right. Aloha kakakiaka, and Andy Collins, and that is also, for those who don't know, good morning in Hawaiian. And I am the education coordinator for Papahanaumokuakea Marine National Monument, working with NOAA. And I am on this cruise. I am one of the science educators, and good to have you with us.
Thank you, Andy. And we'll go to our pilots. Who do we have this morning?
You're first this morning. You're first.
I am.
Introduce yourself.
I am Antonella, Argus pilot, but currently sitting in the Herc seat.
I'm Trevor. I'm sitting in one of these seats. We're using one of the vehicles.
Excellent, thank you.
So moving on to the navigation seat, Aaron Heffron, navigator, not ROV pilot. Yeah, here we are.
Great, thanks. And who do we have in video?
Hello, I am Erin too, and I'm the video engineer sitting on this watch.
Great, thank you, Aaron. So, Chris, we have another hour of observation, exploration, right? And then we're recovering the vehicles.
Yeah,
Right?
we're still pretty deep, so it's going to take a while to get them to the surface, and we're going to try to get them up by 8 o'clock this morning here. Right now it's just past 4, if I'm not mistaken.
Yeah.
So, yeah, so we got an hour. We're going to see what we can see. I was watching a little bit down in the room, so I'm a little bit familiar with what they've been seeing, at least in the last hour or so. And those of you who are watching all these little red things, they probably pointed them out, but they are a type of brittle star. Oh, it's actually I'm trying to think of the common name, excuse me, a gorgonocephalid. It's sort of a straight-armed basket star. Finally came to me. It's a little early here this morning.
Ah, straight-armed basket star.
Yes.
Dredged that one out from the dark catacombs.
Yeah. So what we're coming across right now is sort of a little bit of a nodule field.
Oh yeah.
And these do happen on these seamounts, particular geos. We happen to be diving on a geo, the slope of one, and a geo is a flat top seamount. It used to be an island, and then it became a lagoon after erosion and reef growth, and then it started sinking below the surface, and it's considered sort of a bank until it gets down to about 200 meters. And then once it gets below 200 meters, it's called a geo. And so this is a common sort of progression of how volcanoes erupt, break the surface, and then start subsiding down below the surface. These are really fascinating. This whole process takes millions of years. So we suspect that this particular seamount we're diving on could be on the order of something like 70 or 80 million years old. So it's not a quick overnight type of thing.
Doesn't sound like it. Yeah, it's really fascinating when you see them on the bathymetry maps with that just very flat top. They stand out against the other features on the bottom.
So we're a little bit on one of the slopes of this guyot, so we're not really looking at the flat top, but you can get sort of flat terraces as you're working your way up to the top, and that provides enough sediment, enough conditions to produce these nodules, these little sort of gravel that you're seeing on the seafloor now. They're actually sort of accumulations, little balls, accumulations of a manganese and metallic precipitate. In between these larger formations are pillow lavas, and those of you who are watching the last watch, I'm sure, because we had a geologist on board, I'm sure she was explaining all of this to you folks. So I'm going to stick primarily to critters.
Yeah, we've had enough geology. They filled all the boxes.
Yeah.
Those rock hounds. Or we decided the other day that if a terrestrial rock collector is a rock hound, a undersea rock collector is a rock shark. There's your new term for today.
Yeah, they were sharky last night, weren't they, with filling all the boxes. But we biologists are going to fight back. We've got some of these small rotary containers, and we're going to see if we can find some small unusual things. We are not just going to collect because we are in a monument. It's very sensitive. We're just not going to grab anything. We have to have a really good reason in order to collect an animal. And so hopefully we'll find one or two really good reasons to get something.
Yeah, as Chris mentioned, we are in Papahanaumokuakea Marine National Monument, which is also a World Heritage Site under UNESCO. We have a designation as a mixed site under World Heritage and natural and cultural feature. And we are about in the middle of the east-west extent of Papahanaumokuakea, near Pioneer Bank and Ka'o, or Laysan Island. And in previous dives, right, Chris, this area in Pioneer Bank was one of the highest biological diversity sites you'd seen in Papahanaumokuakea in the deep sea.
Yeah, so Pioneer Bank is a very unusual feature. The surface expression of this bank is relatively small. By that I mean the part of it that's very close to the surface is very small. I'm trying to think if any part of Pioneer actually breaks the surface, or whether, I don't think so, that's right. Maybe it's 80 meters down is the top of it.
Yeah.
But as you go south from this bank, there is this very elongate ridge that runs due south, and it goes for miles and miles and miles. It's something like 25 miles plus, maybe even 30 miles long.
Oh, wow.
And we first dove on that ridge back in 2003, and to everybody's surprise, it was packed with all types of life, sponges, corals, you name it. And then we were able to return a couple times after that, and we dove on different places. So the first time we dove on it was kind of near the top of the ridge where it forms. That was at about 1,800 meters. And then we decided, well, you know, how far does this community extend? It's supposedly 25 miles down to the tip of this ridge, which is very close to where we are right now. So we dove in the middle. Again, bam, tons of animals, you know, all over the place. And then we did a third dive a little further down, and it didn't stop. They're different animals. You see Communities are changing as you go down the rift, but the density remained the same. It's possibly the most amazing site that we've ever dove on, because that means this community is miles and miles and miles long.
That's amazing.
It's really something.
Yeah, and it's really surprising to me how similar the stratification of organisms on these seamounts is similar to like the stratification you might see on a mountain and terrestrial areas. You know, you have certain communities that are located at certain depth bands, and although it's kind of fuzzy, that realm, you can definitely see a stratification of organisms. And right now we're at 2758 meters, so almost 10,000 feet, and it's deeper than what Chris was talking about earlier on that bank, on Pioneer Bank. So we're seeing some different communities, and I bet the rock guys were very happy that they saw that field of manganese, ferromanganese encrusted rocks, because they didn't get to see that the last seamount. So they just got overexcited, basically, is what happened.
Well, the thing is, I was watching that last rock collection there, and it was a beautiful rock, even for a biologist. That's going to be extremely useful to be able to age the seamount. We don't know how old the seamount is. We have no clue. No one's ever sampled it before. No one's ever dove on it before. And so that really was a wonderful collection.
Yeah, so that's what we're trying to answer in this expedition, because you have the entire Hawaiian Ridge and the Hawaiian Archipelago, which was formed from a hotspot that is currently just off of the Big Island of Hawaii and still forming the island there. We have a current eruption on Hawaii Island that's been active ongoing for quite a while, or recently reacted, but it has been continuously ongoing for quite a long time. And that's still forming the Big Island. So these islands on the Hawaiian Archipelago, we know are only will go up to about 80 million years old when you extend the chain up the Emperor Seamount chain all the way up to Kamchatka, Russia. And the last seamount and that from that chain is about 80 million years old. But what we're looking at here is another line of seamounts that intersect the Hawaiian Ridge and the Hawaiian Archipelago in almost southeast to northwest direction, and we're in the southern Wentworth seamounts, and these seamounts are of a different origin. Well, that's what we're trying to figure out, whether they're actually much older, of Cretaceous origin, 100 million years old or plus. So that's why we're collecting these rock samples.
Yeah, and your last watch lead, who was on, Andrea Balbus, she's got a theory that this chain, if everything comes out the way we expect it to, that the chain that this seamount is in could be even longer and older than the Hawaiian chain. Is remarkable. Wow. The Hawaiian chain does not end at the emperor seamounts. The problem is that the Pacific plate is actually going into the Aleutian Trench, and all of the earlier seamounts are now gone forever. We'll
It's the
never
ultimate
know it.
recycling.
It's recycling. It's going back. It's all melting again, going back into the mantle. So we'll never know what those things were. But it's only ending because that's where the trench is. But who knows how long this thing was, and who knows when it originally started. The Hawaiian hotspot, or Pele, excuse me, when she actually was born and started her thing, started creating all of these seamounts.
Yeah, and it's interesting in that the voyage of Pele comes from actually Kahiki, or Tahiti, as it's called today, and came up into the Hawaiian archipelago and then descended down to her home right now, which is Halema'o Crater on Hawaii Island and Hawaii Volcanoes National Park. And so that kind of begs an interesting question, Chris, if this seamount chain extends much further south. I don't think it extends down to Tahiti, but some of these, that could give evidence of the legend of Pele continuing, starting from further south and continuing up and then going down the Hawaiian archipelago. Two different origins, but both volcanic activities from hotspots.
Yeah. So one of the over general goals of all of this work too is that the Pacific Ocean itself is littered with seamounts all over the seafloor, and it's very, very complex because many of these seamounts were erupted at completely different times and different manners and everything else. And right now you have this whole tapestry of all of these seamounts over the seafloor, and trying to untangle what actually happened over millions of years is a very complex problem. And that's kind of it. So we're sort of working our way slowly, seamount by seamount, and looking at ones that could actually reveal at least what a string of seamounts, one string of seamounts in the Pacific, if we can understand that, and we just kind of gradually work and get better and better at understanding what happened here over millions of years.
Yeah, it's a fascinating story, geology for sure. And it's incredible that now we can, with the computers as powerful as they are, they can even start to map the movement of magma in the core up to the crust and look at some of the what might be considered convective currents that in the magma that generate some of these hot spots, like that generated the Hawaiian archipelago and this seamount chain that we're looking at. And it's taken a long time for computing power to get up to that point where they can actually understand how magma is moving around in the core of the Earth.
So I don't, again, we were trying to get some sleep, and we don't really know what was described in some of the previous washes this evening. But this dive was sort of set up so that we started around 3,000 meters, and we're working our way up to break 2,500 meters. We may not make it, but one of the reasons we're doing that is we know that these really marvelous high-density communities, we know that they can exist to depths down to about 2,500, 2,600 meters, but then it looks like they taper off, but we don't have enough data points to actually say that conclusively. We think there's some boundary there that we do not understand. And so we're purposely doing some dives that are a bit lower than where we expect to find some of these communities, just to try to find that boundary. Is it real? Does it exist? Can you get a glorious community down 2,700 meters or so? And looking at the seafloor right now, well, it's kind of supporting that there really is a boundary.
And that boundary is partially defined by the oxygen levels, right? You were looking at that yesterday, the oxygen.
There could be many things involved. It could be, and it isn't necessarily just, a depth boundary.